All right, so welcome to another deep dive, everybody. Today, we are going to be looking at some really cool excerpts from a Vsauce video about space.
Oh, very nice.
Yeah, so get ready to, maybe have your mind bent a little bit because we're going to be talking about orbits and bullets and even like what would happen if you tried to put out the sun.
Mm,
So yeah, it's a lot of like kind of like out there, but it's cool.
I love that stuff. I mean, it's amazing how these seemingly simple questions
Right.
can lead to these really profound insights about the universe.
Right. Like it's really interesting because they're all kind of like, oh, what if,
Yeah,
it's,
yeah.
but then when you get into the science of it, it's like, oh, wow, it's not as simple as you might think.
Exactly.
Yeah. So, the video starts out talking about orbits and how astronauts aren't really floating in zero gravity
Right.
and that it's more like they're falling but missing the Earth.
Right.
So how does that even work?
So think about throwing a baseball. The harder you throw it, the farther it travels before hitting the ground. Yeah. But what if you could throw that baseball incredibly fast, like thousands of miles an hour?
Okay.
It would travel so far that the Earth's curvature would cause it to miss the ground completely.
Okay.
It would essentially keep falling towards the Earth, but constantly missing it, creating a continuous loop.
Okay.
That's an orbit.
So they're basically like in a constant state of free fall.
Pretty much.
That's kind of terrifying, but also amazing.
It is. And the speed needed to achieve orbit around the Earth is mind-boggling. It's over 17,000 miles an hour.
Wow.
To put that into perspective, that's like traveling from New York to Los Angeles in about 12 minutes.
Okay. Wow, that is fast.
It is.
Now, to stay in orbit, does the speed have to be exactly 17,000 miles per hour? Or...
Well, it depends. It depends on a few things. Mainly how far away from the Earth you are.
Oh, okay.
Think of it like this. If you're closer to Earth, gravity's pull is stronger.
Right.
So you need to move faster to avoid falling back down.
Mm.
Further out, gravity is weaker.
Okay.
So you can orbit at a slower speed.
That makes sense. So what about the moon? I remember the video saying something about being able to get hit by your own bullet there.
Yes. So since the moon is much smaller than the Earth, its gravitational pull is weaker.
Okay.
Only about 1/6 of Earth's. That means you only need to travel about 1,600 meters per second to achieve orbit there.
Wait a second. 1,600 meters per second. That's actually achievable with some powerful guns, right?
Exactly. There are guns, like the Paris gun, that can fire projectiles at speeds close to that.
Really?
Yeah. Theoretically, if you were on the moon and fired a bullet horizontally with one of those guns, that bullet could circle the moon and come right back to you.
Okay, that is both awesome and terrifying.
I know, right?
Like, whoa! It really makes you appreciate how different things are out in space.
Absolutely.
Speaking of different, let's move on to the sun. The video asked if you could put it out with water, which seems like such a crazy question.
Yeah. But it's a great way to highlight how the sun actually works.
Right, it's not like a regular fire.
Yeah.
Right.
No, not at all. The sun isn't burning in the traditional sense. Its energy comes from nuclear fusion, where hydrogen atoms are constantly being squeezed together under immense pressure to form helium.
Right.
And this process releases a tremendous amount of energy.
It's wild to think that, like, that process is happening millions of miles away, and that's what's creating our sunlight.
Yeah, it's pretty amazing.
And speaking of sunlight, the video mentioned that even that tiny bit of light reaching us represents a loss of mass for the sun. How much are we talking here?
Well, it's kind of mind-boggling, but the sun actually loses mass equivalent to a medium-sized asteroid every single year, just from shining.
Hold on, an asteroid every year.
Every year.
So over, like, the billions of years the sun has been around, it's lost. I can't even imagine how much mass.
Yeah, it's a truly staggering amount. But even with this constant loss, the sun is so massive, it still has billions of years of life left.
Okay, so maybe trying to put it out with water is a little, ambitious?
Definitely. Yeah. And the video actually explains that adding water would actually make the sun hotter because you're increasing its mass,
Oh, okay.
which would lead to even more intense fusion reactions.
So it's basically a giant fusion reactor that we're all just hanging out around.
Pretty much, yeah.
That's both incredible and makes you realize just how important that delicate balance is.
Absolutely.
And that delicate balance brings us to another interesting point that the video touched on, which is what would happen to a bullet fired in the vast emptiness of intergalactic space? I'd imagine it would just keep going and going, right? I mean, space is pretty big.
It is. But the thing about space is it's not static. The universe is constantly expanding, which means galaxies are moving away from each other.
Wait, so even if a bullet was traveling super fast, it might never reach anything because everything is just spreading out.
Exactly. Especially in those sparsely populated areas between galaxies, the expansion of the universe would likely outpace the bullet's speed.
That is one lonely bullet.
It is. It really puts into perspective just how vast and dynamic the universe is, wouldn't you say?
Absolutely. And it makes everything on Earth seem so close together.
Yeah, it does. It really does.
Yeah.
It really does make everything seem close. Thinking about that bullet, it makes me think about something else the video mentioned. Escape velocity.
Escape velocity, isn't that like how fast you need to go to like escape a planet's gravity?
Exactly. It's related to orbital velocity, but even faster.
Right.
If you reach escape velocity, you're not just orbiting, you're breaking free from the gravitational pull completely.
Okay.
Yeah.
So like if you wanted to launch a rocket to Mars, you'd need to hit escape velocity to like get away from the Earth.
Exactly. And the stronger the gravity, the higher the escape velocity. For Earth, it's about 7 miles per second, much faster than the speed needed to orbit.
Wow, 7 miles per second. That's incredible. Makes you wonder if there's like a limit to how fast anything can travel.
Well, that's actually a question that has puzzled physicists for centuries. But according to Einstein's theory of relativity, nothing can travel faster than the speed of light.
So even if we had like some like super advanced spaceship, we couldn't just like zip across the galaxy in an instant?
Not quite. The speed of light is kind of like a cosmic speed limit.
Okay.
Even light itself, the fastest thing in the universe, takes time to travel vast distances.
Oh, man. That's kind of a bummer. But it also makes you appreciate the scale of the universe even more.
Yeah, it really does. And speaking of scale, remember how we were talking about how adding water to the sun wouldn't put it out?
Right.
Well, the video mentioned another theoretical way to, extinguish a star.
Really? How would you even go about doing that?
It all comes down to density.
Okay.
The sun's energy is generated by the intense pressure at its core, where hydrogen atoms are forced to fuse together.
Right.
You could somehow disrupt that density, spread out the sun's material far enough, those fusion reactions would stop.
So it's like taking away the fuel for the fire, but on a cosmic scale.
Exactly. But of course, manipulating the sun on that scale is purely hypothetical. Definitely not something we'd want to try.
Yeah, I think we'd all prefer to keep our friendly neighborhood star right where it is.
Absolutely. The sun is essential for life on Earth. It provides us with the light and warmth we need to survive. But, like all stars, it won't last forever.
That's right. They have a lifespan, don't they?
They do.
Is that fading out thing we talked about earlier, is that how it happens?
Well, it depends on the star. Smaller stars, like our sun, will eventually expand into red giants,
Okay.
shedding their outer layers before shrinking into white dwarfs, which slowly cool over billions of years.
So like a cosmic ember slowly fading away.
Yeah, that's a good way to put it. But larger, more massive stars have a much more dramatic end. They explode as supernovae, releasing incredible amounts of energy and creating some of the most spectacular events in the universe.
Supernovae, that's where things like black holes and neutron stars come from, right? Yeah.
Exactly. Supernovae are the cosmic furnaces where some of the most extreme objects in the universe are forged. It's a testament to the incredible power and complexity of stellar evolution.
It's amazing how these, like, seemingly simple questions about space lead to such incredible insights.
Yeah, it's a testament to human curiosity, our drive to explore and understand the world around us, even the parts that seem impossibly far away.
You know, thinking about all these vast distances and cosmic events, it makes our little planet seem pretty insignificant.
It's true that in the grand scheme of the universe, Earth is just a tiny speck, but it's also the only place we know of that harbors life,
True.
which makes it pretty special, wouldn't you say?
Absolutely. Okay, before we wrap up, I have to ask you about the ending of the Vsauce video. It asked viewers where they would choose to fire that lonely bullet in the vastness of space. Do you have any thoughts on that?
That's a great question. It really makes you think about the possibilities, doesn't it?
It does. I think I'd choose to fire it towards a nebula. Imagine that bullet, like flying through those colorful clouds of gas and dust, maybe even triggering the formation of new stars along the way.
Wow, yeah.
It'd be like a cosmic art project.
That's a beautiful thought. Nebulae are indeed some of the most visually stunning objects in the universe. They're the birthplaces of stars where clouds of gas and dust coalesce under gravity, eventually igniting into brilliant, shining suns.
And to think, those nebulae we see through telescopes are so far away that the light we're seeing from them has been traveling for thousands, even millions of years.
I know.
It's like looking back in time.
It is. It's a reminder of the incredible scales of time and distance involved in astronomy. And it really makes you wonder what other secrets and wonders are hidden out there in the vast expanse of the cosmos.
For sure. This deep dive has been such an incredible journey. From understanding how orbits work to contemplating the lifespan of stars and the sheer scale of the universe, I feel like I've learned so much.
It's been a pleasure exploring these concepts with you. And I think the biggest takeaway from all of this is the power of curiosity. It's what drives us to ask questions, to seek answers, and to constantly push the boundaries of our understanding.
Right. And sometimes the most seemingly simple questions, like whether you could get hit by your own bullet on the moon, can lead to some of the most profound insights about the universe.
Exactly.
So, to all our listeners out there, keep those questions coming, keep exploring, and never stop being curious about the world around you, both big and small.
Yeah.
Because as we've learned today, there's always more to discover, and the universe is full of surprises. Thanks for joining us on this deep dive, and we'll catch you next time for another exciting adventure into the unknown.